Hey there, gearheads and automotive history buffs. Today we're diving into one of the most experimental and frankly disastrous periods in transmission technology. The 1950s were supposed to be the golden age of innovation, but when it came to gearboxes, many manufacturers learned the hard way that not every idea is a good one. We're counting down 25 transmission systems from the 50s that failed so spectacularly they became cautionary tales in engineering schools. If you love automotive disasters and engineering nightmares, make sure to hit that subscribe button and ring the bell so you never miss our deep dives into automotive history. Let's kick things off with the Packard Ultramatic. Now, Packard was a premium brand trying to compete with Cadillac, and they needed an automatic transmission that screamed luxury. So what they got instead was a system that screamed for mercy. The Ultramatic used a complex arrangement of multiple clutches and a torque converter that would overheat faster than a cheap laptop running video games. The lockup clutch would fail catastrophically, often leaving drivers stranded in the middle of intersections. Packard owners quickly learned that luxury meant expensive repair bills, and the Ultramatic became synonymous with unreliability. The transmission was so troublesome that it contributed to Packard's eventual demise as an independent automaker. Next up is the Buick twin-turbine Dynaflow from the early 50s. Buick thought they had cracked the code with this one, using two turbines instead of planetary gears for the first iteration. Sounds innovative, right? Well, it was also innovative in how it destroyed fuel economy. This transmission was so inefficient that it could turn a V8 engine into something that struggled to pass a gas station. The slippage was astronomical, meaning much of the engine's power was converted into heat rather than forward motion. Drivers complained it felt like they were constantly driving through molasses, and the transmission would often overheat during any spirited driving or hill climbing, leading to complete failures that left owners with repair bills that rivaled the cost of a new car. The Hydra-Matic controlled coupling transmission from Oldsmobile deserves a special place in our Hall of Shame. This system tried to combine a fluid coupling with a mechanical clutch to improve efficiency, but what it actually combined was the worst of both worlds. The controlled coupling would chatter and judder during engagement, and making smooth starts virtually impossible. Drivers reported violent shaking that felt like the car was trying to tear itself apart. The coupling would wear out rapidly, and once it started slipping, the transmission would burn itself up in a matter of miles. Oldsmobile quietly dropped this feature after countless warranty claims made it clear that controlling the coupling was something they simply couldn't do reliably. Let's talk about the Ford Cruise-O-Matic early prototype systems. Before the Cruise-O-Matic became somewhat reliable in the 60s, Ford experimented with several configurations that were absolute nightmares. The early versions had a tendency to jump out of gear without warning, suddenly throwing the car into neutral while cruising down the highway. Imagine doing 60 miles per hour when suddenly your engine revs to the sky and you're coasting with no power. Even worse, some units would spontaneously engage reverse while moving forward, causing catastrophic internal damage and leaving drivers in dangerous situations. Ford had to completely redesign the valve body and gear selection mechanism after too many accidents, and lawsuits made it clear this wasn't just a minor inconvenience. The Rio self-shifter was an attempt by the truck manufacturer Rio to create an automated manual transmission for their commercial vehicles. This thing was a disaster on wheels, or more accurately, a disaster that kept wheels from turning. It used a complex series of vacuum servos and mechanical linkages that were supposed to automatically shift gears based on speed and load. In theory, brilliant. But in practice, the system would regularly select the wrong gear, the servos would leak, and the whole assembly would freeze up in cold weather. Truck drivers hated it with a passion because it would often leave them stuck in one gear, forcing them to limp to a repair shop. Rio trucks equipped with the self-shifter gained a reputation for unreliability that damaged the brand's credibility in the commercial market. The Chrysler M6 semi-automatic transmission was Chrysler's attempt to offer a budget-friendly alternative to full automatics. It eliminated the clutch pedal but still required manual gear selection. The problem was the fluid coupling and the incredibly fragile gear selection mechanism. The M6 would develop leaks from virtually every seal, and the gear selector would become notchy and difficult to operate. But drivers found themselves fighting with the shifter, and the transmission would often refuse to engage gears properly, The fluid coupling would also fail prematurely, leading to a loss of power transfer. Chrysler mercifully killed this transmission after just a few years, when it became clear that semi-automatic wasn't what customers wanted, especially when it was this unreliable. The Studebaker automatic drive deserves recognition for being one of the most frustrating transmissions ever bolted to an American car. Studebaker partnered with Borg Warner to develop this system, but something got lost in translation. The automatic drive had a maddening habit of hunting between gears, constantly shifting up and down as if it couldn't make up its mind. This created a lurching, surging driving experience that made passengers carsick and drivers furious. The transmission also had weak clutch packs that would burn out quickly under normal driving conditions. Studebaker owners became intimately familiar with their local transmission shops, and many simply swapped in manual transmissions to escape the nightmare. Let's discuss the DeSoto PowerFlight early production models. Chrysler's PowerFlight was eventually refined into a decent transmission, but the first DeSoto applications were horrific. The two-speed design was simple in concept, but plagued by hydraulic control issues. The transmission would slam into gear with bone-jarring force, causing broken motor mounts and damaged universal joints. The shift quality was so bad that automotive journalists of the era described it as being hit from behind by another car. The kickdown mechanism would also fail, leaving drivers stuck in high gear from a standstill, which would stall the engine or cause the transmission to overheat and fail. DeSoto dealers spent countless hours trying to fix these issues with limited success. The Lincoln Turbo Drive was Lincoln's attempt to create the ultimate luxury transmission experience, but it turned into a reliability nightmare. This transmission used an overly complex hydraulic system with dozens of passages and valves that were supposed to provide silky smooth shifts. Instead, the intricate hydraulics would develop internal leaks, causing erratic shift patterns and eventual failure. The turbo drive was also incredibly sensitive to fluid condition, and even slight contamination would cause the valve body to malfunction. Lincoln owners, who had paid premium prices for their cars, were outraged when their transmissions failed with low mileage. The repair costs were astronomical because the complexity meant complete rebuilds were often necessary. The Hudson Hydra-Matic installation deserves mention not because the transmission itself was terrible, but because Hudson's implementation of it was spectacularly bad. Hudson bought Hydra-Matic units from GM and tried to adapt them to their step-down design cars. The mounting and cooling systems were inadequate, leading to chronic overheating problems. The transmission would get so hot that it would cook the fluid, causing varnish buildup and valve sticking. Hudson's cooling solution was simply insufficient for the heat generated by the Hydra-Matic underload. Owners found that their transmissions would work fine in cool weather, but fail repeatedly during summer driving. This wasn't GM's fault, it was Hudson's poor engineering integration that created a reliable transmission's evil twin. The Kaiser supersonic transmission was anything but super. Kaiser was struggling financially and needed a competitive automatic transmission but couldn't afford to develop one properly. What they created was an under-engineered mess that combined a weak torque converter with inadequate clutch packs. The supersonic would slip excessively when accelerating, making the already underpowered Kaiser cars feel even more lethargic. The clutches would burn out quickly, filling the transmission with debris that would clog passages and cause complete failure. Kaiser owners learned that supersonic meant super expensive to fix, and the transmission problems contributed to Kaiser's exit from the American automotive market. The Nash Weather-Eye Automatic, not to be confused with the heating system, was Nash's attempt at creating a transmission that could adapt to different weather conditions. This ambitious but flawed system used temperature sensors to adjust shift points, but the sensors were unreliable and the logic was faulty. In cold weather, the transmission would hold gears too long, over-revving the engine. In hot weather, it would shift too early, causing lugging and poor performance. The temperature sensors would fail, sending wrong information to the hydraulic control system, resulting in bizarre shifting behavior. Nash eventually abandoned the weather-adaptive features and went with conventional controls, admitting that their ambitious system was too unreliable for real-world use. The Plymouth High Drive Semi-Automatic was Plymouth's budget entry into automatic transmissions, and it showed. This hybrid system used a torque converter for starting, but required manual shifting through the gears. The problem was that the clutch packs in the transmission were wildly underbuilt for the torque of Plymouth's engines. The high drive would start slipping within months of purchase, and once slippage started, complete failure was imminent. The torque converter would also fail, losing its fluid and leaving drivers with no power transfer whatsoever. The Plymouth owners felt cheated because they paid extra for automatic features, but got manual transmission problems combined with automatic transmission repair costs. The Willys Hydra-Matic adaptation in their Aero cars was a case study in how not to integrate a transmission. Willys, like Hudson, used GM's Hydra-Matic but completely botched the installation. The transmission mount points were poorly designed, causing excessive vibration that would crack the transmission case. Yes, you read that right, the cases would actually crack from the vibrations. The linkage was also problematic, with sloppy connections that made gear selection imprecise. Owners never knew if they were truly in park or if their car might roll away. The combination of cracked cases and poor linkage made the Willys Aero Automatic a car to avoid, contributing to the model's market failure. The Fraser Manhattan's automatic transmission option was essentially a badge-engineered Kaiser unit, which means it inherited all of Kaiser's problems and added a few of its own. The Fraser version seemed to have even worse quality control, with reports of metal shavings found in brand-new transmissions. This suggested manufacturing contamination that would accelerate wear and cause premature failure. The shift quality was harsh and inconsistent, and the transmission would frequently need adjustment just to maintain basic functionality. Fraser owners paid luxury car prices but got decidedly non-luxury reliability, and the transmission problems helped seal Fraser's fate as a short-lived mark. The Packard Ultramatic second generation deserves its own entry because Packard doubled down on failure. Instead of completely redesigning their problematic transmission, they tried to patch the first generation's issues. The result was only marginally better and introduced new problems. The updated Ultramatic added more clutches to improve performance, but this made the transmission even more complex and fragile. The hydraulic control system was still prone to sticking valves, and the increased number of clutches meant more components to fail. Packard owners found that the second-generation Ultramatic was just as expensive to repair as the first, and the transmission's continued unreliability further damaged Packard's reputation. But the Chevrolet Powerglide from the very early 50s had significant teething problems before becoming the reliable workhorse it's remembered as today. The first production runs suffered from weak thrust washers that would fail catastrophically, allowing gears to walk out of position and destroy the transmission internals. The two-speed design meant the transmission worked hard, and the early metallurgy wasn't up to the task. Chevrolet had to quietly upgrade components and improve manufacturing processes to address the failures. Early Powerglide owners experienced failures at low mileage, which was shocking for a Chevrolet product that was supposed to represent dependable transportation. The Mercury-Merc-O-Matic early versions were essentially Ford-O-Matics with different badges, but Mercury seemed to get the worst examples. Quality control issues meant that Mercury applications had higher failure rates than equivalent Ford models. The governor assemblies would stick, causing late or missed shifts. The bands would wear prematurely, leading to slippage and eventual failure. Mercury dealers became experts at transmission overhauls because they performed so many under warranty. The reputation for unreliability hurt Mercury's attempts to position itself as a premium brand because buyers expected better reliability from a more expensive car. The Dodge Gyro-Matic was Dodge's version of the semi-automatic transmission disaster. Like Plymouth's High Drive, it combined the worst aspects of manual and automatic transmissions. The Gyro-Matic used a fluid coupling and manual shifting, but the synchronizers were inadequate, and the fluid coupling would fail regularly. Dodge owners complained about grinding gears and slipping coupling, often within the first year of ownership. The transmission also had a tendency to jump out of gear, which was both annoying and dangerous. Dodge eventually moved to fully automatic transmissions and tried to forget the Gyro-Matic ever existed. The Pontiac Hydra-Matic in the early 50s faced a unique disaster when the Hydra-Matic factory burned down in 1952. This forced Pontiac to use Chevrolet Powerglides temporarily, but the initial Hydra-Matics before the fire had quality issues that suggested manufacturing problems were already developing. Some units had improper clearances and inadequate quality control. After the fire, the rebuilt Hydramatics were generally better, but the 1951 and early 52 models had higher failure rates. This wasn't entirely Pontiac's fault, but Pontiac owners still suffered the consequences of transmission failures and limited parts availability. The Rambler Hydra-Matic suffered from the same integration problems as other non-GM brands using the transmission. Nash Rambler's adaptation resulted in inadequate cooling and poor mounting that caused excessive wear. The compact Rambler body didn't provide good airflow to the transmission, causing overheating during city driving and mountain grades. The transmission would overheat, cook the fluid, and fail. Rambler's attempt to offer a modern automatic transmission in a compact car was admirable, but the execution left owners stranded and frustrated. Many Rambler buyers specifically ordered manual transmissions to avoid the automatic's reliability problems. The Cadillac Hydra-Matic, while generally more reliable than other brands, had significant issues in some model years during the 50s. The complexity of the four-speed design meant there were more components to fail, and certain production runs had weak clutch drums that would crack under stress. When a clutch drum failed, it would send metal debris throughout the transmission, causing catastrophic damage. Cadillac's reputation for luxury was tarnished when owners experienced transmission failures, especially since repairs were expensive even by Cadillac standards. The brand worked hard to improve quality control after customer complaints threatened their premium market position. The International Harvester automatic transmission used in their light trucks was a rugged design that unfortunately wasn't rugged enough. International tried to create a transmission that could handle truck duty cycles, but the early versions couldn't handle sustained heavy loads or trailer towing. The clutches would overheat and fail, and the oil pump was inadequate for maintaining pressure under stress. Farmers and contractors who bought International trucks for work found their transmissions failing when they needed them most. The reputation for transmission failure hurt International's light truck sales and pushed commercial buyers toward manual transmissions or competitor brands. The Studebaker Flight-O-Matic was Studebaker's later attempt at getting automatic transmissions right, but they still struggled. This Borg-Warner-designed unit had a troublesome lockup mechanism that would engage and disengage erratically, causing surging and poor drivability. The valve body was overly complex for the era's manufacturing capabilities, resulting in sticking valves and incorrect shift patterns. Studebaker's financial problems meant they couldn't invest in proper development and testing, so customers became unwitting test subjects. The Flight-O-Matic's problems were another nail in Studebaker's coffin as buyers lost confidence in the brand's quality and engineering capabilities. Finally, let's talk about the various Dynaflow iterations that Buick kept trying to perfect throughout the 50s. While later versions became acceptable, the early and mid-50s Dynaflows were oil-hungry, inefficient, and prone to failure. The reliance on fluid coupling rather than mechanical gears meant constant slippage and heat generation. The transmission would literally boil its fluid under hard use, causing seals to fail and internal damage to occur. Buick kept adding more stators and trying different configurations, but the fundamental design was flawed. Owners loved their Buicks but hated the Dynaflow, often trading their cars specifically to escape the transmission's problems and abysmal fuel economy. So there you have it, 25 transmission systems from the 1950s that proved innovation. Sometimes means expensive failure. These transmissions taught engineers valuable lessons about hydraulics, metallurgy, quality control, and the importance of adequate testing. While they caused headaches for their owners, they paved the way for the reliable automatic transmissions we enjoy today. If you enjoyed this trip through automotive disaster history, give this video a thumbs up and let me know in the comments which failed transmission you think was the absolute worst. Don't forget to subscribe for more automotive history and engineering deep dives. Thanks for watching, and I'll see you in the next one. Now, before you head off to watch another video, I want to take a moment to really dig into what these transmission failures meant for the automotive industry as a whole. You see, the 1950s were a time when manufacturers were racing to prove they could innovate faster than their competitors. And that pressure to innovate sometimes came at the expense of fundamental engineering principles. The companies that survived and thrived weren't necessarily the ones with the flashiest new ideas, and they were the ones willing to admit when something wasn't working and go back to the drawing board completely. What's fascinating is how many of these failed transmissions share common problems. Overheating was a recurring nightmare. Inadequate cooling systems combined with inefficient designs created a perfect storm for transmission destruction. Hydraulic complexity was another recurring theme, as engineers kept adding more valves, more passages, and more electronic controls without fully understanding how all those components would interact under real-world conditions. The metallurgy of the era also played a significant role. The materials available in the 1950s simply weren't as advanced as what we have today. So transmissions that seemed robust on paper would fail when exposed to extreme temperatures and pressures. But quality control is perhaps the most important lesson from this era. Many manufacturers assumed that once a transmission design left the factory, it would perform as engineered. But production variations, contamination during assembly, and inadequate testing meant that the gap between theory and reality was enormous. Some of these transmissions would fail within months or even weeks of purchase, suggesting that the manufacturing process wasn't catching defects before they reached customers. This destroyed brand reputations and left owners with justified anger and massive repair bills. The human element in these failures cannot be overlooked either. Mechanics of that era were trained on mechanical systems, and suddenly they were facing complex hydraulic and electronic transmissions they didn't fully understand. Repair shops had to develop new expertise, invest in specialized tools, and figure out how to diagnose problems in systems that were completely different from anything they'd worked on before. Many small-town mechanics simply couldn't afford the investment to service these new transmissions properly, leaving rural customers with limited repair options and enormous bills from distant dealerships. Let's also consider the economic impact on the companies themselves. Warranty claims for failed transmissions cost manufacturers millions of dollars during an era when that money could have gone toward better engineering, improved testing, or more cautious product launches. Some of these companies, like Packard, Kaiser, and Fraser, simply couldn't absorb the financial blow of millions of dollars in warranty repairs. On the combination of transmission failures, poor sales, and financial difficulties created a cascade of problems that led to company closures and mergers. From a customer perspective, purchasing a car in the 1950s with an automatic transmission was taking a genuine gamble. Buyers had to weigh the convenience of automatic transmission against the very real risk of expensive failure. This pushed many customers back toward manual transmissions, which meant that the automatic transmission revolution was delayed in some market segments. It wasn't until the 1960s and 70s that automatic transmissions became truly reliable and efficient enough that nearly all car buyers preferred them over manuals. The engineering lessons learned from these failures became cornerstones of modern transmission design. Engineers learned that hydraulic systems needed better filtration and monitoring. They learned that torque converters needed improved stouter designs and better fluid formulations. They learned that clutch packs required higher quality friction materials and more robust cases. They learned that thermal management was absolutely critical and that undercooling a transmission would kill it just as surely as over-torquing it. Every modern transmission carries the DNA of fixes that originated from these 1950s disasters. If you're restoring a 1950s car today, understanding these transmission issues is absolutely essential. Knowing which transmissions are reliable allows you to make informed decisions about restoration routes. And some restorers deliberately source different transmissions or go back to manual gearboxes specifically because of the reputation of the original equipment. Others embrace the challenge of rebuilding and modifying original transmissions to make them more reliable. The aftermarket has flourished partly because of the shortcomings of original 1950s transmissions. This deep dive into transmission failures also reminds us that nostalgia can be deceiving. Those beautiful 1950s cars we see in movies and television shows had real reliability issues that are easy to overlook when you're admiring the chrome and the tail fins. The owners of these vehicles lived with genuine frustration and danger. A transmission that fails on a highway at 55 miles per hour isn't just an inconvenience, it's a safety hazard. Modern drivers are genuinely blessed with transmission technology that our predecessors could only dream about. As you venture into the comments section, I'd love to hear from you about your own experiences with classic cars. Have you owned a 1950s vehicle? Did you encounter any of these problematic transmissions? What modern automotive systems do you think we'll be laughing at in 50 years as we look back at the learning process? The automotive community has incredible stories to share, and your perspective matters. Comment below, and let's continue this conversation because learning from automotive history means we can make better decisions going forward. Don't forget to hit that subscribe button if you haven't already, because we've got more automotive deep dives, restoration stories, and engineering disasters coming your way. Ring that notification bell so you never miss when we upload new content. Check out our other videos in the automotive history playlist to explore more fascinating and sometimes terrifying aspects of car development. Share this video with fellow gearheads and automotive enthusiasts who would appreciate this journey through transmission technology gone wrong. Thanks for sticking with me through this detailed exploration of 1950s transmission nightmares. Your support means everything to this channel, and I genuinely appreciate every view, like, and comment. I'll see you in the next video where we'll explore another fascinating corner of automotive history.